Hello everyone, welcome back to the lecture series on the foundations of deep learning, concepts and applications. In the previous session, we had seen biological inspiration for neural networks, the mathematical representation of a neuron. We have also seen what is perceptron and basic components of a perceptron. We have seen a perceptron learning model, and we have solved one numerical example where we have learnt the working mechanism of a perceptron learning model. Today in this session we will see types of perceptron. Then we will solve once again one more numerical problem, and we will take an OR gate truth table, and then we will solve a problem. Then we will look into, there is a limitation, there are certain limitations with respect to single layer perceptron. Once we complete this concept, once we understand the single layer perceptron limitations, then we will go to the implementation of single layer perceptron. And here in the implementation we will be using Google Colab. So first for few minutes we will understand what is Google Colab, let us get familiarized with the Google Colab environment, and then we will see the implementation of single layer perceptron. So we will look into what are the different types of perceptron. There are two different types of perceptron. We have a single layer perceptron and we have a multi-layer perceptron. Now what exactly is a single layer perceptron? Single layer perceptron is one form of ANN which is mainly designed for linearly separable problems. Now what exactly is a linearly separable problems? Now when you look into this diagram, here we have a data set. When you plot the points between the two different classes, we can clearly able to separate them with a straight line. So this is called a linearly separable data. So perceptron, single layer perceptron is one which is designed for a linearly separable patterns. And how does the architecture of single layer perceptron looks? The architecture consists of only an input layer and it will have an output layer. So here between input and output we will not have any hidden layers. And since there is only one output layer, the activation function that is used here, as we have seen in the previous session also, the activation function typically used is either we will have a step or a threshold activation function. And the single layer perceptron is the one which is mainly suitable for binary classification, where you will have the classes either yes or no, 0 or 1, true or false. And here we have seen the perceptron learning rule does not use a backpropagation concept. So this is what is the theoretical concept. So when we say the perceptron learning rule, here the perceptron learning rule is used to update the weights. So how do we update the weights? What is the formula? The new weight is old weight plus change in the weight. So delta W is given by a learning rate and the target minus computed, multiplied with the target minus computed, and then we will multiply it with its associated input, and this has been added with the new old weight to get a new weight. So these are this is a formula which is used to update the weight. Likewise we will also be updating the bias, and the formula used to update the bias is this. And diagrammatically, if we have to understand the single layer perceptron, this is the diagrammatic representation. So theoretically what we have seen, we will just have only input and then the output layer. We will not have any hidden layers in between. That is what is single layer perceptron. And the neurons that are used at the activation function that is used at an output layer will be a step activation or a threshold activation, and it is mainly designed to solve a linearly separable problem. Linearly separable problems are those problems where when you plot them on a two-dimensional graph, you can able to clearly separate them using a straight line. There is one major limitation with respect to a single layer perceptron. What is that limitation? It cannot handle a non-linearly separable data. So it cannot handle this. this. So what do you mean by non-linearly separable? So here is the diagram. So when we look into this, you cannot separate the two classes with the straight line. So this is what is non-linearly separable data. So single layer perceptron cannot handle this. That is the reason we have a second type of perceptron called a multi-layer perceptron. What is a multi-layer perceptron? It is once again a neural network model which is mainly designed to handle both linear as well as non-linear separable problems. If that is the case, how does the architecture of multi-layer perceptron looks? The architecture will have something called, we will have an input layer, we will have an hidden layers, and we will have an output layer. So we will have hidden layers, and we can have one or more hidden layers in the architecture. And because we have an hidden layer and then we have an output layer also, there are different activation functions that we will be using for an hidden layers, and there are different activation functions that we will be using for an output layer. So you will study more in detail about various activation functions in the upcoming sessions, but for this particular session you only try to understand there are different activation functions that will be used at an hidden layer, and there are different set of activation functions that will be using at an output layer. So the at an hidden layer mainly we will be focusing on using non-linear activation functions. So such as it can be a ReLU, it can be a leaky ReLU, etc. So multi-layer perceptron, using this particular model you can solve both the regression as well as the classification tasks. Whereas we have seen previously the perceptron, single layer perceptron is more suitable to solve an classification problem, and more specifically we will be focusing on a binary classification. But whereas when you take a real world problems, you will have a multi-class classification, you will have a regression problems. So in that case single layer perceptron comes with certain limitations. Therefore we will be going for a multi-layer perceptron which is suitable for both the classification as well as the regression task. Now here also we will be updating the weights, we will be updating the bias. So which means you have to after once we calculate, get the output, once we calculate the error, we have to come back and then update the weights. So in single layer perceptron we were using a simple perceptron learning rule to update the weights, whereas in a multi-layer perceptron we will be using a back propagation algorithm. So again in detail you will be studying in upcoming sessions, but for now multi-layer perceptron will use the back propagation algorithm with the gradient descent and different variants of gradient descent to update the weights and then the bias. And more this multi-layer perceptron we use to solve more real world problems where non-linear decision boundaries are involved. If this is a theory concept, theory behind the multi-layer perceptron, diagrammatically we can able to see multi-layer perceptron looks something like this. So we have seen some time back we have an output layer, then we have an hidden layer, and as usual we will have an input neurons. So here when we talk about the hidden layer, we can have one hidden layer or we can have more number of hidden layers. And when we say this is a neuron, here also we have a summation and we will have an activation. Here also we will get a summation and there is an activation, summation and activation. So in previous session we have seen how input gets multiplied with the weight. The same concept is applied here as well. So here this summation is the input which is coming from this and the weight associated with this, the input and the weight associated, input and the weight associated, this input and the weight associated, and so on and so forth. And the output of this will be this value, and that will be multiplied with this weight, and then you will have a summation. We will have a summation and we will have an activation function here also. So since there are activation functions in all of these places, there are different activation functions that we will be using. There are different set of activation functions we use at an output layer, and there are different set of activation functions that we use for an hidden layer. And more specifically we will be going for a non-linear activation functions at an hidden layer. Yeah, so as we have seen in the theory, this is used to solve both linearly separable and non-linearly separable also. Even if we have a data set which is of this nature, if you have data where you cannot able to separate that with a straight line, you can still able to solve this problem using a multi-layer perceptron. So this is all about the different types of perceptron. We have two types, single layer perceptron and multi-layer perceptron. Now let us take the second numerical example where we will be still solving using a single layer perceptron only, and here we are taking an OR truth table. If you look into this, this is an OR gate when you where you have two inputs, therefore there are two neurons, and then if you look into this, it's a binary classification problem. You just have an output either 0 or 1. Therefore, the number of neurons that you are placing at an output layer is just one neuron. Now, from the previous session we have seen how exactly the single layer perceptron update the weights. We have an weight updation formula. So, using that we will be updating the weights. Here is an example where intentionally bias is not being taken, but that does not mean that there is no bias. Definitely there will be a bias term also that will be added, but for this example we are not considering the bias. The focus is only on updating the weights, but otherwise the bias term is also being included here. When we see the hands on, I will be using a bias term also. So, there is an you require there is a summation and there is an activation function, and the activation function that we are using is a threshold activation where a threshold value is 0.5. Anything the value greater than or equal to 0.5, the value will be 1, less than 0.5 the value will be 0. This is what is an activation function that we are defining for this problem statement, and this is the learning rate that we have defined. Okay. So, with this let us look into how to solve this, and this is a diagrammatic representation of an OR data set. If you take this, when both the inputs are 0, you have the value 0. When one of the value is 0 and when one value is 1, we have a value 1. When one input is 1, when other input is 0, the value is 1, that value is this, and when both are 1, when both x1 and x2 are 1, we get this value. So, you can see clearly there is a difference between two classes. When we plot this data set, there is a clear differentiation between. This is a class 0, all this points belongs to class 1. So, between these two classes, we can able to clearly separate them using a line. So, this is what is the single layer perceptron concept, where it mainly used for a binary classification, works very good for a linearly separable data. So, let us solve this. Since we have solved one problem very detailedly, I will be showing you for one epoch for this particular problem. I will pause for a few seconds where I want the readers to solve the problem, and then you can come back to the particular slide and then you can verify your answer. So, let us look into how exactly we are going to solve this particular problem. So, since we have seen there are two inputs, the very first input what we are considering is 0 and 0. We have considered 0 and 0 as the first set of input. What is the target value for this particular input? The target value is 0. Okay. So, what is the first step? The first step is we calculate Z. How do we calculate Z? X1 W1 plus X2 W2, and there is a bias term also, but we are not considering the bias term, but otherwise there will be some constant value, a small constant value that will be added here. What is X1? X1 value is 0, and what is the weight? Weight is 0.1, and what is X2? X2 is also 0 and the weight is 0.3. So, definitely the value is 0. So, and this is less than a threshold. What is a threshold value that is defined? The threshold is 0.5. Since the value is less than threshold, the predicted value is 0. So, we can say the computed value is 0. Now, the next step is, that is what we have seen, the computed value is 0, and the target directly we are taking it from the data set that is given to us. You can see there is a target, we have taken that target as it is. The next step what we are doing, we have to calculate the error. What is the formula to calculate the error? Target minus computed. What is the target value? 0. What is the computed? The computed is also 0. So, the error what we are getting is 0. Okay. Once we get an error 0, now we have to ideally there is you have to go back and then update the weight. Now, how is that you will be updating the weight? Although in this particular example you don't, for this instance we don't require, because the error is 0. But still, let us see how do you update the weight. The update weight is, let us see how we are getting this 0. So, the learning rate is 0.2 and the error is 0, and you are updating the weights with respect to x1, x1 is also 0. So, delta W value is 0. So, we have seen delta W value is 0. Similar way, let us see how delta W2 value we are getting. So, let us look into how delta W2. So, delta W2 is error learning rate is 0.2 and the error value is 0, and with respect to x2 we are calculating, x2 is also 0. Therefore, delta W2 value we are getting 0. Now, once we get this, what is the total complete formula? W new is equal to W old plus delta WF. Now, what is when we are doing for W1, what is W1 old value? 0.1, and what is this delta W, what we got is 0. Therefore, W1 value is still 0.1 only. And similar way, if you have to do W2, W2 is old weight. What is old weight of W2? 0.3. And what is change in what is this delta W2? This is also 0. So, when you add, you get 0.3. So, the weights are W1 and W2. For the next input will be the 0.1 and 0.3 only. So, with this, I hope you have understood how it is being solved. I will show you for one complete epoch, whatever you are seeing on this table, I will be solving this. Now, the next input that we are considering is 0 and 1. We are considering the next input. Now, for this input, what is the target? The target is 1. Okay. So, what is the first step? As usual, we have to calculate Z, which is x1 W1 plus x2 W2. Once again, I am saying there is a bias term, but here we are not considering it. What is x1? 0. What is WF? So, WF is 0.1, and what is x2? x2 is 1 and the W2 value is 0.3. What is the Z value? This term becomes 0. So, this is 0.3, which is less than a threshold. Therefore, Y dash is 0. So, computed value what we are getting is 0. Now, what is the target value for this input? The target value for this input is 1. So, what is the next step? We have to calculate the error. How is the error is calculated? Target minus computed. Target is 1. So, the error is 1. So, now we have to update the weights. So, what is the formula to update the weights? It is W new is equal to W old plus delta WF. So, now since both W1 and W2, so first let us calculate delta W1. So, how is that we calculate delta W1? Learning rate. So, what is the learning rate? So, let us erase this part and then take the value directly. So, the learning rate here is 0.2, and what is the error that we have got? The error we got is 1, and with respect to input x1 we are updating. Therefore, this is 0. Delta W1 is 0. That is what is the 0 that we have got here. Now, let us update delta W2. So, here only I am changing. How do we go for W2? Learning rate is 0.1, error is 1, and the input is now 1. Instead of 0 previous, now we will be taking input 1. So, for this, let us calculate what is the value that we get. The value that we are getting is 0.2, that is the 0.2 value that we have written. Now, if there is a change, now you have to update back into this W new value. So, there was no change with respect to delta W1. So, let us not see, let us look into how do we update W2. W2, what is the old weight? The old weight was 0.3. For this, change in delta W is 0.2. Therefore, it is 0.5. So, the new weights are W1, since there was no change, it is 0.1, and the W2 value is 0.5. That is what you are seeing, that for the next input it is no more 0.5, it is 0.3, it is 0.5 now. So, what is the next input that we are considering? Let us erase. So, we have seen it is now 0.5. The next input is 1 and 0. So, on a similar lines, when you compute, the first step is Z. You will calculate x1 into 0.1, we will get 0.1 plus x2, since it is 0, it is 0. So, it is 0.1, which is less than the threshold value. So, y hat is 0. So, y hat is 0. And what is the target for this input? The target for this input is 1. So, what is the error? Target minus computed, which is 1 minus 0, which is 1. Okay, once this is what is the target and error. Now, we have to calculate delta W1. So, what is the learning rate? 0.2. What is the error? 1. And what is the input? Input is 1. So, it is 0.2. Delta W1 is 0.2. And what is the new weight? The new weight is, what was the old weight? 0.1 and the change 0.2. So, now we are updating W1 to 0.3. We have updated W1 to 0.3. So, similar way you can check for W2 and you can see how we are going to. So, this is for one single epoch which I have solved the problem. I will be pausing here for a few seconds, where I want you to complete it for one more iteration, for one more epoch, and then see is there any changes in the weight. How long you will continue to do this? Can you see here in the error everything should be 0. So, here we still have one of the sample which is still getting misclassified. So, until this column, error column turns to be 0, you will be repeating this process. So, towards the end, once you complete solving the entire, okay, let me go back and then show. Once you complete the first epoch, then the final weights what we have got is 0.3 and 0.5. So, for the next epoch, the weights that we consider, our problem statement will be something like this. The weight will be 0.3 and 0.5, and then once again you will pass 0, 0, you will check for 0, 1, we will check for 1, 0, and we will check for 1, 1, and then we will solve the entire, we are going to get this table. Then we are seeing that still there is some misclassification. So, for the next epoch, whatever is the last updated weight, that will be used for the next one. So, for this you will have the graph something like this. You will have the weights 0.5 and 0.5, and then you check, you repeat this, you will see all the points are correctly classified. Therefore, what we are understanding by solving this particular problem is, initially the weights that we had considered was 0.1 and 0.3, but after we have solved the entire problem, after we have updated the weights, we have understood that 0.1 and 0.3 are not the correct weights. The correct weights are 0.5 and 0.5. This is how you will update the weights using a perceptron learning rule. Okay. So, with this we have come to the end of a theory part of single layer perceptron, where we will see what are the limitations of single layer perceptron. Why we will not use single layer perceptron more to solve a real world problems. First of all, from all the concepts, all the topics that we have seen, what we have understood, single layer perceptron can only classify the data which is a linearly separable one. What is linearly separable data? Where you will have a straight line. You can able to separate two classes using a straight line or an hyperplane. Now, but what if we have a data where you cannot be able to separate them using an straight line, then single layer perceptron cannot be solved, which is that one example. When you take an XOR problem statement, you cannot separate them using a straight line. So, because of this, this is the first limitation. And what is the second limitation? It is primarily designed for a binary classification problem. But what if in a real world, what if you have a multi-class classification problem, and what if you want to solve a regression problem? Then you cannot directly use a single layer perceptron, the original model that is being designed as it is. We cannot use. We can use by using certain modifications or by doing a certain extension. So, this is the second limitation of single layer perceptron. And the third and the most important one is, you have seen from both the problems what we have solved using a single layer perceptron, we had assumed the weights. So, what if the initial assumption weights are too large, or it is too small, or you have not properly chosen the weights? Then you will be keep solving the problem. It will take it takes more time to train the model. So, this is and it may even get stuck in a wrong decision boundary. So, it may never reach the correct one. So, it is very, very sensitive. The performance of single layer perceptron is very sensitive to the initial values of its weights. So, these are certain limitations of single layer perceptron. So, with this, as I told, we have come to an end of a single layer perceptron. So, before we move into the next topic, let us quickly have a summary of the entire what we have learnt. So, this is primarily been inspired from a biological neural system, and where the inputs are entered into an neuron, and here the inputs are x1, x2 and so on up to xn. These inputs are taken from the data set. With every of the input, there will be a weights that are associated. So, this is a cell body which we call it as a neuron, primarily responsible for performing two mathematical operations. The first mathematical operation is it performs the summation of input multiplied with the weight, and then we will have x w transpose x, and then you will be adding it to a bias term, and whatever the resultant value that we are getting, that resultant is passed to an activation function. And since it is a single layer perceptron, the activation function that we will be using here is an step activation function or an threshold activation function. Now, the output of the neuron, since it is mainly used to solve a binary classification, you will have a value either 0 or 1. So, once you get the output, the next step we will be calculating the error. How is that we calculate the error? The error is given by the formula target minus computed. So, this is the formula that is used to calculate the error. Now, once the error is calculated, we will calculate delta W, change in the weight. So, how much change you need to do for the weight? So, delta W is given by the formula learning rate, and that is multiplied with the error, and that is multiplied with the associated input xi. Now, this is given to a formula W nu is equal to W O fold plus change in this weight delta W. So that becomes a new weights for the next input or for the next epoch. So this is what is the total summary of a single layer perceptron. So with this we have come to an end of an theory session. Now let us look into a simple implementation of a single layer perceptron. For this let us take an example of the problem that we had solved in one of our session. We will take the same input and then we will see how we can implement a single layer perceptron. And since we are using Google Colab to implement it, let us first see some of the basic concepts of Google Colab and then we will get into the implementation of it. First step is go to Google and then log into your Gmail account. Here I have already logged into my Gmail account, and the very first step, give Google Colab, give Google Colab, and then go to the first link here, welcome to Colab. So here you will be you will get this particular window, and here you can see at the bottom new notebook. Click on this new notebook. It will take few seconds for you to open this. So this is what is a Google Colab notebook. Now if you look into this, on the top you can able to change this and then give, since it is an first program that you are learning, you can give any of your file name here. Now if you look into this, most of you will be familiarized with Python. Whenever you write a Python program, you will be saving a program with the .py. But here if you look into, we are saving the program by default with the extension IPYNB. We are saving a program with IPYNB. What is this IPYNB? It is an interactive. I stands for interactive, PY stands for Python, and NB stands for notebook. Now, why is that it is called as an interactive Python notebook is, now whenever you are working on Google Colab, it is just not a Python program that you will be writing, you will have some rich text elements also. What do you mean by rich text element? Now, for example, here we are writing a simple A is equal to 5, then we write B is equal to 3, and then we will go for simple A plus B, and then we will print C. This is a simple program that we have written. Now when we execute this particular cell, we will be able to see the output. So let it take time. Once you execute this, you will be able to see the output. Now you can see there are so many at the top you have a menu bar, and the menu bar has the file, you have an edit, we have a view, we have a insert, runtime, tools and help. Now when you go to files, you can able to see all of these options. Now you can able to save this, you can save a copy in your drive so that you will not be losing it. You can, if at all, if you have an GitHub account, you can save a copy into your GitHub also. And you can open, if at all, if you already have some file, you can open a new notebook. If you have some other notebooks you want to upload that, you can use this option. So as and when we go through this course, we will be exploring each one of this option. Now you can able to see that there is an output that is being displayed. Now you have a code here and we have a text. So I click on text so that the text is displayed. Here I am going to write something. This is a simple this is a simple addition of two numbers program. So I have given some description about this. I made it as a bold, and then we are running this. How did we run? I have pressed shift enter. So here I have used shift enter. Now when you look into this particular when you view this, you can able to see there is some text that is written, there is a program that you have written, and you can able to see the output also here only. So it is more of an interactive Python notebook rather than just writing only a Python code. Later when you run, you see an output differently. Instead of writing just a Python program, you can able to view everything very clearly here. So this is all about some of the basics that are required for you. Now let us understand what exactly is Google Colab. Now why is that we require to use this Google Colab? Google Colab, it is a free cloud based Jupyter notebook, and it is a service which is provided by Google, and here you can execute a Python program without any explicit installations that are required. And Google Colab is something which is especially useful when you are dealing with machine learning and deep learning. Now why it is very important to use Google Colab when you are dealing with machine learning and deep learning is, you can see in the runtime we have something called as a change runtime type. When you click on change runtime type, you have a provision to use GPU as well as you have a provision to use even a TPU also. So these are high processing units, which is very much useful for us when we are working on real time large amount of data. And by default it is a CPU. In case if you want to change, you can select any one of this, and then you can click on save, and you have to do all these things before you start doing your writing your code. You can first go change the runtime type and then save whichever accelerator that you require as per your problem statement, and click on save. So this is a simple basics that are required for you. Now here you can see how much what is the configuration that is given to you. You can able to see here the RAM and so much of RAM that is allotted, and this much of disk space that is allotted for running this particular program. So this is what is the basics of Google Colab. With this basics, we will explore more about this as and when we deal with other hands-on. We will also learn how to import the data. How do you upload if there is you have a large amount of data, you don't want to store it in the drive, you want to use it directly from the link, you have an online link where there is a data. All that we will see as and when that part of a concept, that part of an hands-on concept is taught to you. So with this, we will quickly look into a single layer perceptron. For this single layer perceptron, the data that we are taking is this. I hope you remember we have solved a problem. So you can have this solved problem with you, so that you can able to relate the answer step by step when you have implemented it using Python. So here we have taken x1 and x2 as the value 1 and 2, and the target value is 1, and then we have weights initialized as 0.2 and minus 0.5, bias 0.1, and learning rate 0.1. These are the values that we had taken to solve a problem. What is the very first step? You go back once again and then recall the perceptron learning rule. The very first step is you have to initialize certain parameters. So what are the different parameters that we are initializing? We require weights, we require bias, and then we require a learning rate. And here the input what we are taking is 1 and 2. and the target value is 1. So, the very first step, if there are any necessary packages that are required for us, we have to import those packages. Since it is a simple perceptron model, we are dealing with some numerical operations. We are doing x into WF and we are adding it to bias. We are doing a simple basic arithmetic operations. Therefore, we are importing numpy as NP. So, once you write this, execute a cell, then you will be initializing all the parameters that are required. So, we have defined an x and we have taken it as an array, list of elements, and then we have taken a target value as 1, and then the weight, we have taken the 2 weights, this is a bias and then the learning rate. So, you can execute it either by using shift enter, or we can execute it by pressing on this icon. So, the next step, I hope you can remember, we had repeated that particular problem almost for 3 times to get the correct parameters. So, the same thing you have repeated again and again, right? What was the first step? You have calculated, first you have to calculate x into W, x1 plus W1 plus x2 into W2 plus bias. So, that is what is the first step that we are doing. So, it is written in this way. So, we are it is a dot product between x and W, and we are adding a bias, and because it is a dot product, it is a part of numerical numpy. Therefore, we are writing NP dot dot. And once we calculate the net input, that is, once we calculate z, is it not we are passing it to an activation function? What is an activation function? Step activation function or a threshold activation function. If the value is greater than 0, then the answer is 1, else the answer is 0. So, whatever is the resultant value, if this value is greater than 0, then the output will be 1, otherwise the output will be 0. Then this is how you are getting the predicted value. Once you get the predicted value, we calculate the error. What is the formula to calculate the error? If you remember, it is a target minus a computed value. So, how do we get the target? Target we have already defined as y. So, y minus y predict. So, it is target minus a computed, y minus y predict. Once this is done, we want to visualize what is our z, what is the predicted value, and what is the error. So, these 3 print statements are used to visualize the values that we have obtained. Now, once we calculate the error, what is the next step? Is it not we update? What is the formula to update? It is W is W plus learning rate eta into the error target minus computed into its associated input x. So, this is how you update the W, and this is the line which is used to update the bias. Once we update W and bias, we are going to print those values. This is for one epoch. This is for one epoch. Now, you will be repeating this for 3 different. You had repeated the same operation for 3 different times, right? So, you instead of writing the same code 3 different, you are putting it into a for loop. So, here I am running it by showing this. So, we can able to see, I want you to compare this with the answer that you have obtained by solving this. In the previous session, we had solved the entire problem. So, the net weight what we have obtained is minus 0.7 and the predicted value is 0, the error is 1, and by updating the weights, we are getting a new weights and a new bias. Then you had repeated the same problem second time. When you had repeated, you got the z value as a minus 0.10. The predicted value is 0, error is 1, and with these, when you updated, we got the value 0.4 and minus 0.1, and this is the updated bias. Then again we had run once again because still we are getting an error here. So, when we repeated this process again, the z value what we had got was 0.5, this is the predicted value and this is the error. and these are the updated weights, and this is the updated bias. So, this is however the problem is being solved on a similar lines, the implementation is also being done. This is a simple single layer perceptron implementation one, and this is when a new data is passed. The new data, if you remember, during a testing time we were passing a new data. So, when we pass a new data here, the new data that we passed here is this. For this we have again calculated Z, we have passed it to threshold, we have printed all those values, and the prediction that it has made is, you can able to see the predicted value is 1. This is what is the implementation of a single layer perceptron. So, with this we have seen the theory behind a single layer perceptron, and we have also learnt a little about the basics of Google Colab, and then why we require Google Colab. Even if our laptop doesn't, if our system doesn't support with high configuration, if we use Google Colab, you can able to still run machine learning and deep learning algorithms. And then we towards the end we had seen an implementation of a single layer perceptron. Thank you.